All right, good evening, everybody. Thank you so much for being here with us tonight. We appreciate it, and it's good to see so many names that are familiar and quite a few new ones as well. So for those of you who may not know me, my name is Jennifer Coffey, and I have the pleasure of being the Executive Director of ANJAC, the Association of New Jersey Environmental Commissions. I want to thank Liz Ritter, who's here with me tonight, kind of manning all the tech, and we have a couple ANJAC staff on as well. So that's wonderful. We appreciate it. This is our second session in our Back to School Climate mini series. And so we invite you to go ahead and go backwards and check out the first session. If that's not yet on YouTube at ANJAC Views on our channel, it will be soon. So keep a watch out for that. And we will put this session up too. What's that, Liz?
It is on YouTube.
Oh, wonderful. Excellent. I can't keep up with our own staff. We're so busy. So tonight we are talking about ocean, wildlife science, and renewable energy. We're talking about marine mammals and avian research. And as I said, our first session was the Arctic meltdown and why that matters to New Jersey. So we invite you to go back and watch that on YouTube at ANJAC Views. And this is tonight's session. And we are pleased to have with us one of our two experts. Our thoughts are going to be with Dr. Kohut, Dr. Josh Kohut, and hope that he is able to join us a little later this evening. And I'll introduce our esteemed speaker, Dr. David Mizrahi, in a moment from New Jersey Audubon. So thank you for being with us tonight, David. And then our third session is at our 49th Annual Environmental Congress, which starts next week. I can't believe next week is mid-October already. I'm not entirely sure how that's happening. And we are bringing to you representatives from Ørsted and Atlantic Shore Winds, who represent the companies that are proposing the first two offshore wind developments off of New Jersey's coast. So we want you to hear directly from them and to ask your questions of them directly. But tonight we're going to talk about the science. And I want to thank all of you for your support. Many of you here, I recognize your names. You are regular attendees of ANJAC programs. You donate to ANJAC when you are able, and we very, very much appreciate your support, both in attendance and in dollars. So if you can, as we are approaching the end of year and we think about end of year giving and Thanksgiving for the work of those that we appreciate, if you could keep us in your thoughts and spread the word about the great work that ANJAC is doing, or at least we hope you think we're doing great work, we would greatly appreciate it. We hope to see you next week, both virtually and in person if you are able. We have virtual events running next week from October 11, 12, and 13, and then in person on the 14th. So in person on the 14th at Mercer County Community College. All the info is on ANJAC's website, so go ahead and check that out to register. And so again, this evening, it is my great pleasure to have with us here this evening, Dr. David Mizrahi. And he is the Vice President of Research and Monitoring at New Jersey Audubon. For the last 20 years, Dr. Mizrahi has led a team of scientists to develop science support tools to address major wildlife conservation issues in the state, the region, nationally, and internationally. Currently, these efforts include conservation of migratory shorebirds in the Delaware Bay and hemisphere-wide, including the federally threatened red knot, assessing effects of habitat management on nesting birds, along power lines right-of-ways, evaluating impacts of offshore wind energy development on migratory birds. So thank you for sharing that knowledge with us here this evening. Determining the adverse effects of contaminant exposure on birds in the meadowlands and other urban landscapes. Status and distribution of federally threatened black rail in New Jersey, and assessing the effects of habitat management on grassland birds at military airfields. So Dr. Mizrahi is certainly busy here in New Jersey with an enormous amount of research. We were sharing a little bit before we started the session, and I said I grew up in Philly, and I never knew birding was a thing, and I never thought much about birds. So I didn't know what I didn't know, and this wonderful world opened up to me when I went to Stockton College, now university, of discovering the magnificence of birds, but also the special place that New Jersey holds in our location for birds coming from the north and coming up from the south. So I am just thrilled to have Dr. Mizrahi with us tonight so I can continue to learn more about what I didn't know I didn't know. And so thank you so much for being here with us this evening. I'm going to turn it over to you to share your screen and go ahead and enlighten us this evening.
Thanks, Jennifer, for inviting me to talk to Anjak tonight. Let me share my screen. And just let me know, Jennifer, if you've got me, my first slide.
Yep, we've got you. It's all perfect. Thank you.
Great. So Jennifer asked me to talk a little bit tonight about offshore wind energy development, and I'll use the acronym OWED. You might hear me say that, so you know what I'm talking about when I say it. And the potential impacts on aerial biota and the research that's really been ongoing over the last several years to really look at what those impacts could be. And I say aerial biota, I'll talk almost exclusively about birds, but you should know that bats and dragonflies and butterflies often are found migrating or traveling along our coasts or over open ocean. So although I'm speaking about birds, just keep that in mind. So today I'm going to talk about potential impacts. The structure of my talk today will be focused on these potential impacts like habitat loss, avoidance and displacement, which is kind of a form of habitat loss, and mortality and injury. And within each of those, I'll briefly describe or point to some of the methods that are used to study those kinds of impacts. And I'll present some results from various studies, most of which have taken place outside of the coast of New Jersey, but in some cases very relevant to what could be happening along our coast when wind energy comes. And then I'll sort of move into sort of the meat of what needs to happen for us to better understand those potential impacts, looking at collision risk, species vulnerability, and cumulative impacts on bird populations. So I wanted to start by just giving you guys a sense of how much is being planned for the outer continental shelf of the U.S. Atlantic coast. Right now, lease areas based on information from the Bureau of Ocean Energy Management is around 4 million acres, and the planning areas, that is those areas that could eventually see wind energy development, that totals 34 million acres, and about 2/3 of that total is in the Gulf of Maine. It's a very large area with a lot of wind energy potential. So these areas that are in purple are the planning areas. The areas in yellow and red are those areas that are already leased and procured. That means procured means that there's a buyer for the energy once wind turbines start spinning in the water. So it's a lot of area, and the potential for habitat loss for animals that are using those areas or maybe using those areas is great. And so the first thing we have to really understand is how animals are distributed and how many there are across that oceanscape. And that gives us an idea of where we might be able to put wind power and where maybe it's not as good an idea. And the Bureau of Ocean Energy Management is really interested in those data. They've helped support a number of studies. States that are looking to have offshore wind developed and bringing energy to their residents in their states are also interested in all of this. Everybody wants to be sure that we're developing these resources with other resources in mind, so we're minimizing the potential for impacts. And the ways that we collect those kinds of data about the abundance and distribution of birds in the oceanscape is through doing surveys by boat or doing aerial surveys and counting or enumerating and characterizing the species and what they're doing, and with high definition aerial photography. This is what some of the data could look like once collected. And these are what we call heat maps. This was a project conducted by the New York State Energy Research and Development Authority, and they contracted a company called Normando and APEM to collect these data. And based on the occurrence of birds on the water, they developed these maps that show high concentrations, red being the hottest or the areas with the highest concentrations, and blue being the coolest. And they did these surveys along transects that ran perpendicular to the coast of Long Island and then along the coast of Long Island. And they did this in different seasons over several years. I'm just showing you the data from 2018 into the early 2019. You can see that most of the activity is taking place in the spring, fall, and winter, and very little in the summer. These are really important sort of foundational information about the occurrence of birds on the outer continental shelf, in the area of the New York Bight and off the coast of Long Island. Here is a similar kind of data, but with a slightly different twist. This is specifically focused on 3 species or species groups. Sea ducks, there are a couple of the species that occur in the offshore waters of New Jersey and all along the mid-Atlantic and New England coast are called scoters. There's 3 different species. 2 species of loons, common and red-throated loon, and an ocean-going bird called a northern gannet. So these surveys were very focused on these groups of species, and they were and the surveys were able to discriminate those birds in the data stream that was being collected. And then what the Biological Research Institute, which did the study, did was overlay those data onto existing maps where offshore wind energy development was planned or sort of in the future taking place. So you can see in the left-hand figure where for scoters, again, the red areas are the areas with the greatest density. Then densities diminish as you get further away from the shore in yellows, and then in blues and light greens. And so you can see for scoters, there's very little area of overlap for the 2 wind energy development areas that are off the coast of Delaware and the Delmarva Peninsula. Similarly for loons in the center figure, but for northern gannet, there seems to be a lot of overlap in the areas of wind energy development or planned wind energy development at the mouth of the Delaware Bay, and then also off the coast of the Delmarva Peninsula. So another kind of potential impact is what we call avoidance and displacement, and this, in fact, is sort of a subset of habitat loss. And what that means is that birds may want to be in a certain place, but because a wind farm is on that footprint of the place that they want to be, they can't use that place. So they're displaced. And when they encounter a wind farm, they'll avoid it. And in some respects, we like that the birds are avoiding the wind farms if, in fact, there's a potential for them to collide with operational wind turbines. But it's also a problem if the wind energy facilities are in areas that are important for birds, meaning there's food there for them. This is a place that they historically use, sometimes offshore underwater shoals that attract fish or places where birds want to be. Now, some of the methods that are used to study avoidance and displacement behavior are marine radar, visual observations, satellite telemetry, and digital aerial surveys, like I explained in the earlier slide. And on the bottom left, you can see roseate tern with a satellite transmitter on it, and on the bottom right, a picture of a radar unit and some high-powered binoculars. And I just want to make a point to say that avoidance can occur at different scales. Birds can avoid the entire wind farm. They can travel through the wind farm, but avoid the the great majority of wind turbines as they fly a path through the wind farm. But there's also avoidance at the turbine level. Like, can a bird avoid interacting directly with a single turbine? So here's some data that were collected in Europe, in and around the North Sea, and in Denmark. In the upper right is our data that show the tracks of individual birds as they approach a wind farm off the coast of Denmark. The red dots are the locations of existing wind turbines that were in the water when these data were collected, and you can see the great majority of the tracks of birds, those black lines, avoided the wind farm completely. The species are not. Radar can't tell you anything about the species. It just will record the object that is being detected by the radar. But some birds do actually travel through the wind farm. And this is where things get a little bit tricky for birds. But if this wind farm was placed in an area that wasn't an important feeding area for the birds that were passing by, then this may not have been a problem. This wasn't a problem. On the bottom right is a figure that basically shows the relationship between red-throated loons and existing wind farms in the North Sea, off in the German region of the North Sea. So all of those gray polygons are wind farms, and all of the different colored dots are locations of red-throated loons that were detected during aerial survey transects that were flown. You can see the sort of the diagonal lines that cut across that figure. Those are the routes that the plane took when they were flying these aerial surveys. And I think the take-home message here is that there was a strong effect. That is, red-throated loons seem to avoid wind farms, and that effect was really strong, up to 5 kilometers, but was significant up to 15 kilometers. Now, on the bottom left, I'm showing a photograph of a wind turbine with one turbine blade painted black. And there have been some experiments to suggest that if you paint one of the turbine blades black, then that actually helps birds to detect that during the time that the turbine may be spinning, and so it helps birds avoid interacting with a single turbine, which is where the issues become a reality. So you have a chance that the bird may collide. So one of the things that people think most about when they think about the potential impacts of wind energy development on birds is collision, and that can result in injury or in death. And in most cases, a bird that's injured is likely going to die anyway, but sometimes they can be recovered. But in the oceanscape, in offshore wind energy development, this is very unlikely occurrence. That is, what I mean to say is not that a collision is an unlikely occurrence, but that you can actually quantify an occurrence of collision in the oceanscape. A bird hits a turbine or a turbine propeller, and it's going to fall into the water, and nobody is ever going to know that. And I'll talk a little bit about modeling collision risk and then cumulative impacts, because that's basically what you have to do, because you're never going to be able to quantify the number of birds that are going to collide with wind turbines. And so how does a wind energy company compensate for the loss of that wildlife, whether it's endangered or protected by any state? So some of the methods that are typically used are vertical and horizontally scanning marine radar. That picture on the bottom left is a picture of our mobile marine radar unit that we've used to study bird movement patterns along in the Gulf of Maine, and then on Block Island and in other places. Liz, I see you have your hand up.
Sorry, that was a mistake.
Okay, I thought so, but I figured I better check.
Thank you.
And on the bottom right is a picture of a piping plover. This is a federally protected species under the Endangered Species Act. It's considered threatened, and you can see the long antenna coming out from behind the bird. This bird's carrying a radio transmitter, and I'll show you some data about that. So one of the ways that we try and understand what the potential for collision is to understand these large scale movements of birds as they travel, say, from their breeding grounds to places where they might winter, or places where they stop en route to their final non-breeding destinations. On the left, the figure showing migration routes of 16 different piping plovers that were marked on their breeding grounds in Massachusetts and Rhode Island, and then there are pathways, and you can see that their pathways actually cross through several of the wind energy development areas offshore. Very, very clearly, the large wind energy development off the coast of Massachusetts, and then some of the ones that are slated for the New York Bight, and even crossing into the ones that are slated for development off the coast of New Jersey. Same type of figure on the right, but for data collected for the federally listed red knot, which is a large shorebird. If you guys don't know about that, it's a very important species that comes to the Delaware Bay every spring to eat horseshoe crab eggs. And these are birds that were marked in either Delaware Bay or in Massachusetts, and then their migration pathways were recorded by the radio telemetry devices, or transmitted by the radio telemetry devices. So the purple lines, or the blue lines, show the movement of birds during the spring migration, those birds that were marked in Delaware Bay, and the green is for birds that were marked with the radio tags during fall migration. Again, red knots pass through those offshore wind energy development areas, so this is obviously a cause for some concern. So if we want to look at local scale movement patterns and how that might be informative about the potential impacts to birds, we typically use marine radars, and two different kinds. I'm not going to go into the details of how these radars operate. I just wanted to show you some of the data. The data that I'm showing here are birds that are migrating around Block Island. One of the first offshore wind energy development areas was in Block Island Sound. There are now 5 wind turbines operating there, and these data basically give us a sense of how many birds are moving, what direction they're moving from, and how fast they're moving. And those are important information when we start to develop collision risk models. And it's also important in terms of developing some very localized avoidance behavior. So we can look at how many birds will avoid wind turbines with this kind of data generated by small marine radar units. Very similar to the data I showed you from Denmark. This is another kind of radar that we use. Typically, it's oriented somewhat differently and allows us to measure the altitude that birds are flying. And this is really important. You know, some birds are going to be flying above wind turbines. Some birds are going to be flying below wind turbines. That is what we call the rotor-swept area, the area that is described by the rotating turbine blades. And we need to know that. We need to know how many birds are flying above and below, how many birds are flying within what we call the rotor-swept zone, and the proportion of those. And so we get a sense of how many birds are exposed to some risk of interacting with wind turbines. And interacting doesn't necessarily mean that they're going to collide, but they encounter the wind turbine, they're exposed to the wind turbine, and they react in one way or the other. Sometimes we think that in most cases they're going to react in a way that avoids collision. In some cases they may not. And it's important to understand that a lot of the birds that we are concerned about or interested in understanding migrate at night or are active at night in terms of their movement patterns. Songbirds, shorebirds, many different water birds are active at night and migrating at night. I just wanted to show you this just to give you a sense of what the data could look like. Once we take all of the data that we've collected, we can develop these histograms that show us incrementally how what proportion or how many birds are migrating at different altitudes above sea level. And that's what you see here. All of these graphs on the y-axis are altitudes in meters above sea level, and on the x-axis the proportion of individuals that we detected during our projects using marine radar. This one was done in the Gulf of Maine. And then we can start to look at even more closely at how many birds are in the zone of concern. That is from, say, 0 to 200 meters. Offshore wind turbines are going to extend 200 meters or greater into the atmosphere. And so as we get further offshore, turbines are going to get larger to generate more energy because the cost of putting those turbines out on the water is greater, and bringing the energy onshore is greater than if you're doing it on land or close to shore. So now we have all this information, but we can't really measure how many birds may be impacted by these by interactions with the wind turbines, and so we need to sort of develop models that might help us estimate how many birds potentially will be at risk of interacting or colliding with a wind turbine. And we have a variety of different inputs, of which I've given you information about several. We want to know, the rate of avoidance, how many times birds actually avoid interacting with a wind turbine, or are they attracted to wind turbines? We have information about the flight density or flight height distribution. Information about the turbine itself. How high is it? What's the diameter of the rotor? That is the sweep of all the turbine blades. How fast is the turbine spinning? Different information about the bird, how long it is, how large it is. Smaller birds may be more effective at avoiding wind turbines than larger birds. They may be more maneuverable. Different flight speeds. Smaller birds may fly slower than larger birds. Some birds are flying at 60 kilometers an hour, so approximately 35 to 40 miles an hour during migration. And then all of that information brought into various kinds of modeling efforts to look at collision risk, how many birds per month may be exposed, what we can expect in terms of avoidance, and how much uncertainty do we have about that estimate. And then what does that mean in terms of mortality? I just wanted to show you, this was an application of a collision risk model that was done for wind energy development in Belgium and in the North Sea. And basically they did this for seabirds on the left of that graph, and on the right for migrating songbirds. Different kinds of information collected for the different groups of species that were of interest, but basically you're counting the number of birds, you're looking at flight heights, and then looking at that information in relation to the wind turbine characteristics, the turbine blades, how fast they spin, how high it is, does it extend above sea level, and then an estimate of the number of collisions through a collision risk model that was developed in 2012 by William Band, and then estimating those per turbine per year over the entire wind farm, all wind farms in the Belgian offshore waters, and then extrapolating to the North Sea and trying to understand what that impact level could be for bird populations. So it's important to note that not all birds are at similar risk. Some species are at more risk than others, and it depends on their general behavior, their flight behavior. How high do they typically fly? How maneuverable are they? How many hours do they spend in the air? Are they active at night or during the day? What about their habitat use flexibility? Are they flexible? Like if they can't use a certain site that they have used, can they use different other sites? And then the sort of the demographic properties, that is population size, survival rates, and how many offspring do they produce in a given year? How long do they live? These also play an important role in how vulnerable species might be to impacts from wind energy development. And then finally, but certainly not least, is their conservation status. That is, if it's an endangered or threatened species, then we have much greater concern about what those potential impacts could mean for a population than a species that may be incredibly common, in the millions of individuals. I didn't want to talk about the graph. The graph on the right is really just to show you that the number of birds, that the groups of birds, the different kinds of birds, the number of individuals that interact with wind turbines varies from these are not species, but these are orders of different birds, and the numbers of different birds from these different orders. This is actually a graph from a study done on terrestrial birds. So this is not applicable necessarily to offshore wind energy development, but it just gives you a sense that not all species are created equal in terms of their vulnerability. So when you have all of this information about species vulnerability and collision risk and information about how flexible they are, their foraging behavior, and all of these other things, you can start to really look at what is really important here, and that is cumulative impacts. Because this is not a one-off situation here. Turbines are going to be in the water. They're going to be in the water for 20, 25, 30 years. So you're going to have impacts that will extend over generations of birds and over populations and species across a large time frame. So our understanding of how this will translate into population level effects over time, that cumulative impacts, is really, really important. And understanding those cumulative impacts, you really need to sort of bring in all of the information that I just spoke about. Displacement and collision and affecting feeding habitats or attracting birds to new and novel feeding habitats, barriers to movement, whether the birds have to increase their flight distance to avoid wind farms, additional energy consumption because of that. And change how that affects breeding output for birds that may be traveling between breeding areas and offshore feeding areas. How does this affect the survival of the young that they produce? And obviously their own survival if they're spending time during the non-breeding season on the open ocean, like a lot of these birds do. And then folding in any reduced survival because of collision. And then that has an impact on overall population size and the viability of those populations over time. So I'm going to wrap up just by giving you a little bit of information about what we think the most important priorities are as far as on the horizon. And you should know that there's a really focused effort by a number of groups and consortiums of groups that include developers and regulators and conservation NGOs and academics to really hone in on answering some of these questions and providing the data that will allow us to understand these impacts and make better decisions about where to put wind energy development on the ocean and how to operate them. So we have a number of different working groups: Regional Wildlife Science Consortium, New York State Energy Research and Development, their environmental technical working group, and there are a number of different taxonomic specific groups. I'm on the bird and bat subcommittee. Then there's the National Renewable Energy Lab, and their groups that are looking at different research priorities and knowledge gaps. And some of all of these entities are coming up with some very common themes: a centralized data portal, standardized research methods and protocols across projects. This is really important because then we can roll up all that information from Massachusetts, from Rhode Island, from New Jersey, from Virginia, from North Carolina, and really start to understand this, because these birds are operating at that scale. You know, you have a bird that may be breeding in Canada, migrates to the offshore waters of Massachusetts, crosses the New York Bight, or the Mid-Atlantic Bight, and then, you know, spends a winter in the offshore waters of North Carolina. They operate at the scale we need to understand their movement patterns and information at that scale. Before, after control impact studies are really important. What were the birds doing before we put wind energy in the water, and what are they doing after? Especially important is quantifying the movement and migration patterns for non-waterbird species. We don't know a lot, or at least the focus has been mostly on birds that spend most of their lives on the water, but not birds that traverse over the ocean that may be affected, like songbirds and shorebirds. And then model these potential for long-term adverse effects on populations. That's the cumulative impacts. My last slide is really to just tell you a little bit about some of the new technologies that are coming out. Solar-powered GPS satellite transmitters are becoming small enough to put on birds like red knots. And that's really important information that you may hear something about in the next talks in the series. Automated species identification from high definition digital aerial imagery really will mean we'll have information much more quickly than manually identifying species like these Bonaparte's gulls in the picture below. Devices that can measure the impact of a bird hitting a turbine blade or hitting the nacelle or the support structure, really important. We go a long way to having us understand what those potential impacts can be for collision. And then LiDAR data being used now to measure flight altitudes, which is really important. So that's all I have for tonight. And I think if there's any questions, if we have time for questions, Jennifer or Liz, I'm happy to answer those.
Wonderful. Thank you. I really appreciate that, Dr. Mizrahi. That was a lot of really great information. Yes, we do have some questions. Maybe you could stop sharing your screen unless
I can stop sharing unless if somebody wants me to go back, I can.
There we go. I want to let our audience know that we have not heard from Dr. Josh Kohut this evening. He was confirmed for today, and our thoughts are with him and hope that he is well and his family as well. And so we will be in contact with him and see if we can't reschedule at another date and time to bring you the marine mammal portion of this program and speak about all of the really great research that Rutgers is leading up through Are You Cool? And not just because it's a really cool name, but because it's great information and great science. So we will be on that and stay tuned. But we do have a few questions, Dr. Mizrahi. So this first one is really a general migration question. And it's, are the spring and fall species numbers that are the highest seasons for Long Island much higher because of migration? If so, does that mean the summer and winter numbers are year-round residents mostly?
Well, that's a really good question. I think you're right. I think the numbers are highest because of migration. But I think if we went back to that slide, you'll see that the numbers for what the researchers are calling winter, I call the non-breeding season, are pretty high as well. So what happens is you get sea ducks and loons that are migrating. So you're detecting those during migration, and then some of those are passing through and will spend the non-breeding season, say off the coast of New Jersey, much closer to the shoreline, or in, off the coast of Maryland or Virginia, and they won't turn up in winter. But it represents, I think, the highest numbers because of migration.
Great, thank you. Our next question is about the offshore wind turbines. If it's hard to quantify the potential impacts to offshore wind on bird species, how will the actual impacts be able to be quantified? And please feel free to share your screen again, because I know you did get into a little bit of that.
Well, let me make sure I understand the question. So if it's hard to quantify the potential impacts of offshore wind on bird species, how will the actual impacts be able to be quantified? So I think what I meant was very specific. It's going to be hard to quantify collisions. I think we can quantify what the habitat loss and displacement could look like. But you're right. I think what we do is we use the best available information, and then we say, okay, given this scenario, what's the likelihood that a bird will be impacted by the footprint of a offshore wind energy facility? How many birds are being displaced, and what do we know about how birds that may be displaced from foraging areas will affect their overall survival or affect their ability to raise young? What's that impact look like? We have a lot of information about that, about how, and not in the context of wind energy, but when foraging food resources are not available to the levels necessary to raise young, what happens? We understand that. And that's why these before after control impact studies are really important. So if large numbers of birds are using a certain area, and now we're going to put a wind energy facility in that area, that means birds may not be able to use that area to feed. They'll avoid it, and there may not be an alternative in close proximity that allows the birds to exploit those resources, and they may need to move. What does that mean? Well, I mean, I think it's a difficult thing to deal with, but all of those inputs together, and it's going to be our, best, based on the best science we have, coming up with what the potential impact will be. And then it's a dialogue between the natural resource agencies, the developers, the conservation organizations, the academic institutions, to come up with what seems to be the most reasonable and effective way to mitigate, whether that's mitigation in operations. It could be mitigation right up front. We're not going to put the wind farm here. We're going to put it somewhere else because we know this could displace an important component of a bird population. So it's, doing this in the offshore environment is incredibly tricky. I think Dr. Carr would tell you how difficult it is to do these kinds of research projects on the ocean. It's incredibly difficult. The logistics are difficult. The cost is difficult. The measurements are difficult. They can measure whale sounds much easier than we can record birds in the atmosphere.
Sure. We've got another question. Does it make any sense? And I'm not sure if this is for you, Dr. Mizrahi, or maybe we can remember this question for our next session as well, when we have the representatives from the wind energy companies with us. Does it make any sense to reduce danger to birds to use towers that are vertical only without blades, but can rotate around and develop energy? And it's okay to say you don't have an answer to that question.
Well, I think I know what the where the question is going. I mean, there are turbine designs that would probably have may have less of an impact because they're not propeller designed. They have some designs that look like egg beaters. They have some that sort of like a blades rotating on a cylinder that sit on top of a tower. Mm-hmm. I don't really know the answer because I'm not an engineer, and I can't tell you how many wind turbines, you may what's the trade-off in terms of, energy produced per hour of operation. So I can't answer that, but
Yeah, we
those are
that
worth
question.
exploring.
Yeah, we can bring that question forward to the wind energy companies in our next session. But yeah, I know if anybody is ever driving through Philly and you're looking at the sports complex as the Eagle Stadium, which has changed name so many times, I can't remember what it's called. In my memory, it was the Lincoln Financial Field. But when you're on 95 South, you can see some of the caged wind turbines without the blades. They've just got internal, like swirled together rotating blades that catch the air coming off of the Delaware River and really make that, I think it's the greenest stadium in the United States, not just because it's Eagles green, but because of the work they've done on sustainability and energy conservation and renewable energy production. But they're pretty cool to see as you're driving down.
They also, a lot of those wind turbine designs also operate efficiently at much lower wind speeds than these large wind turbines with the 3 propellers that we're most familiar with.
Yeah, great. So I'm going to skip around. We've got a question from one of our environmental commissioners about the species vulnerability graph. And I don't know if that's something you want to go back to on your slides or not, but regarding the species vulnerability graph, he says there's huge error bars, the biggest he's seen. Can you comment on that?
They're not my data, Paul. I can't tell you what those error bars mean. And I just really wanted to sort of give you a visual verification that not all species are equal in terms of their vulnerability. I can go back to and let's see, take a look. I'm going to stop that. So, and these are orders of birds. These are not even species. These are orders. So like this one here, where I don't know if you can see my my
Yep,
cursor.
We can see your cursor.
This is anseriforms. These are ducks. Passeriforms. These are mostly songbirds. Gruiforms, cranes, columbiforms, pigeons. I don't know what those error bars really mean and what the dots mean. I tried to get into the paper that actually had this graph, and it was difficult for me to understand. But I mean, I think in one case these are collisions per. So on one axis, one of the x-axis is collisions per turbine per year. And on the other axis, it's number species. I don't think it's number of species. I think it's numbers of individuals of different species. That was my understanding. But sorry, Paul, I can't shed more light on that.
Great, thanks for taking a run at that. There's another question here. Again, I'm skipping around just a little bit. Will the results of the peer-reviewed studies and research by all these research entities be available before the projects are constructed?
Well, that's a good question. I think yes, in some cases, and no, not until the wind farms are already in the water. Because we're a little behind here on, so for instance, there's a couple of projects that are going to be in the water in Massachusetts before there was any information about what those projects might be displacing in the way of bird habitat. And it'll only be after the facilities are completed that we'll have an understanding of the after effects. And so it's really important to get that before component. And I think we have a chance to do that in New Jersey because, the projects are in the early stages. I mean, the leases have been awarded. And I think that Ocean Wind actually has a procurement agreement with BPU. And I know that they and Atlantic Shores are actively engaging researchers to collect data on what we think are the most important problems. We're collaborating with some of the researchers that are working on the projects.
Yeah, thanks, Dr. Mizrahi. And if I'm not wrong, there are some fairly strong monitoring components for after the turbines are constructed. And the location of them, which hopefully we'll get into in our next session, was guided in large part by mapping that's under the acronym MARCO from the Mid-Atlantic Ocean Plan. That was a great effort to map what humans use the ocean for, so IT lines, shipping lanes, cultivated shellfish beds, and what nature uses the area of the offshore area of our ocean for, migration, natural shellfish beds, fisheries areas, and to try to make smart decisions about the location of them. But certainly there's an enormous amount of information that's being developed right now from the work that's going on. Thank you.
Yeah, I'll add, well, just before we move on, I'll add that in
Uh-huh.
2000, in mid 2000s, New Jersey DEP contracted a company called Geomarine to do what they call a baseline ecological study. And they did a lot of the kinds of boat surveys and aerial surveys that I described in my talk. And that showed a distinct drop off in the number of birds that were on the water as you moved away from the shore, and about at 7 or 8 miles. And that's why these projects are now sited probably between 8 and 12 miles offshore, and why the Fisherman's Energy project that was proposed for the nearshore waters off Atlantic City was not, because it was within 3 miles. So yeah, I think as quickly as those data can be used by developers and the regulators, the better we are at all meeting our collective objectives.
Great. So we've got a couple other questions. We've got another innovative concept here from a great environmental commissioner. Are the turbines able to broadcast sound to help the birds avoid them?
Yeah. Well, I mean, they do produce sound, very low frequency sound, and birds can probably hear that, but so do the waves breaking on the coastline produce low frequency sound. So whether a bird can distinguish between the sound of waves breaking on the shoreline or the sound of water, the movement of water on the ocean and turbines is uncertain. Some of the technologies that people are working on, and I didn't talk about this, is how to actually increase avoidance. At that micro scale, how do we ensure that birds don't collide with turbines? And in the case of bats, high frequency sound being emitted from a turbine is one of those kinds of things that people are working
on. Right, that's really interesting. So we're not going to be blasting like Bruce or anything to try to get bird avoidance.
Hope not.
No Bruce or Bon Jovi. I'm going to give the last question here to another EC member who asks, I've heard that wind turbines can be designed to create artificial reefs to attract fish. If that is done, wouldn't that represent an increased attraction for birds?
Well, I think that's a really good question by Walter. In fact, wind turbines don't need to be designed to create artificial reefs. They will create artificial reefs just by their being. So you're anchoring a structure in the water column. So it's in most cases. In the Gulf of Maine, it's a little different because they're, 13 miles offshore, you're in 300 feet of water. So they're going to be looking at floating platforms which have their own issues. But for what Walter is referring to, I mean, if you put a structure in the water column, marine organisms will attach themselves, that will attract fish, and this will attract birds. And I don't know that there's any way to get around that. I mean, if you're going to put a turbine in the water, this is what's effectively going to happen. And some of the species don't seem to be deterred by the wind turbines when they're on a mission to catch fish, and so that may make them susceptible to collision. Some of the sea ducks eat macroinvertebrates, large, mussels and clams and other things that attach themselves to structures like artificial reefs in shallower water. So wind turbines that are further offshore, that are in deeper water, may reduce that that risk because their birds won't typically dive, in 50 or 60 feet of water, 20 to 30. Okay. But the fish eating birds that may be diving on fish that are feeding around wind turbines, that's a different story.
That's great. Well, thank you so much for being with us this evening. Clearly, we needed at least a whole hour and probably several more to talk about wind research and birds. And I appreciated learning a little bit more about your research and what's happening in New Jersey. So thank you again, Dr. Mizrahi. And thank you everybody for being here with us this evening.
Thank you, Dr.
We invite you to
Mizrahi.
register for our Environmental Congress 49th, which starts next week, Tuesday, Wednesday, Thursday, virtually, and in person at Mercer County Community College in West Windsor on the 14th. So I'm looking forward to seeing you both on Zoom and in person next week. Take care, everyone.
Thanks, everyone. Bye now.
Thank you, Dr. Mizrahi. Thanks, everyone.
Thank you. Bye.
Bye-bye.
Good night.